Now in this lesson, we're going to look at percent composition and how to obtain the empirical formula or that simplest whole number ratio of a compound to determine the compound's identity. So let's start with the first one on your worksheet, which is KMNO4. We know that potassium weighs 39 and manganese weighs 54.94, and then oxygen is 64 because it is 16 for each. So the total mass of potassium permanganate is 157.94. So we're starting with 157.94. grams per mole. To get percent, you always do part over whole. Because we put down potassium as 39, we're going to use that. So potassium weighs 39, and we divide that by 157.94, and then multiply it by 100% to put us into percent. So I'm going to give you a minute to do that, and check your answer. Yes, it's 24.7%. So it's 24.7%. Now let's do the manganese. We know that manganese weighs 54.94, and we have 157.94 total. Multiply it by 100%, and we'll get the contribution that manganese has in this compound. Again, I'm going to give you a minute to calculate it. Yes, we have 34.8% manganese. Now the last one is oxygen. We can either add these up and subtract from 100, but let's go ahead and calculate it just to make sure, and we'll wait to add it up to check our answer. So we said that there are 4 oxygen, so it's 4 times 16, so it's a total of 64. Divided by the 157.94 grams times 100%. Again, I'm going to give you a few minutes to calculate it. Take all the time you need. Yes, we would get 40.5%. Now let's add this up and see how close to 100 we were able to get. Yes, 100% exactly. Now, what would be the range of an acceptable answer? I'll give you a minute to answer that. Good job. The range of an acceptable answer would be between 105% below, above, and 95% below. So an acceptable range of that would be the 5% rule. All right, now let's do the next one. How many grams of oxygen can be produced from the decomposition of 100 grams of potassium chlorate? Now to do this, we need to know what part of this 100 grams would be the fractional part of oxygen's contribution. So the way we can do that is we can do it like a ratio. So we know that for every however many grams, we'll know how many grams of oxygen we have. So let's calculate the molar mass of this first. So potassium is 39 plus chlorine is 35.45 plus 3 times 16 is 48. So our total mass is
students, we would like to remind you that the discipleship building is now closed.
122.45.
Unless you are in the library meeting with a teacher or with your parents, please exit
So
the building
this is
at this time. Thank you.
the part that oxygen is contributing to this compound. So we know that oxygen to the whole part, right, potassium chlorate, will give us our ratio. So we have 48 grams is to 122.45 grams as what is to 100. Now we can just cross multiply and get our answer. I'll give you a minute to get that. Great. You should have gotten 39.2 grams of this is oxygen. Now let's look at our next question. How much iron can be recovered from 250 grams of iron 3 oxide? Iron 3 oxide, 250 grams, how much iron can we recover? Again, we're going to have to do the part over whole and then take it out of the 250. So I'm going to give you a minute to set that up, and then I'm going to put the answer on the board. Okay, the total of the iron 3 oxide is 159.7 grams. Now, we have 250 grams, so the total of given is 250 grams. We know oxygen's part is 48 because there's 3 grams oxygen, and we want to find out X. We want to know how much oxygen would be in 250. Well, if there's 48 and 159, it makes sense that there would be more than 48 in 250. So just multiply 48 by 250, cross multiply, divide by 159.7, and go ahead and write down your answer. Yes, it is 75 grams of oxygen in iron 3 oxide if we had 250 grams of iron 3 oxide. This last one I'm going to let you do on your own, and you can come and show me in class, and then I will, well, you don't need to show me. You can go ahead and write it down in the answers, because I'll give it to you as a multiple choice question. All right, now let's do the next step. The next step is calculating the formula from the percent composition. We don't know what this formula is. All we know is that we have potassium and we have chlorine, and they're adding in some ratio. I don't know how much of each I have. Well, I can work backwards. I can say that let's have 100 grams, because it doesn't matter if I have 1 gram or 100 grams, I'm going to have the same ratio. And that's what a formula is. A formula is the whole number ratio. So if I have 100 grams and 52.7% is potassium, then it stands to reason that I have 52.7 grams potassium in that 100 grams. And I have 47.3 grams of chlorine in that 100 grams. I want to do the simplest whole number ratio, which is the mole ratio. So I would divide by the molar mass, and that would tell me the number of moles. So on my card, potassium is 39.1. And chlorine is 47.3 the amount, and so its molar mass is 35.45 for every 1 mole. So we would have, go ahead and write down the answer. I'll check it. 1.35. So we have potassium, 1.35, and chlorine. Again, write down your answer, and then I will check it. 1.33. So we would divide by the smallest number, and we would see that it's a 1-to-1 ratio. So the formula is KCl, because it's a 1-to-1 ratio. You just divide by the smallest one. And then when we divide this by 1.33, it's a little off, but it's still very close to 1, extremely close to 1. So you just divide both of them by 1.33. Okay, that's the formula for that. Now let's do a little harder one. This next one is aluminum. Again, we're going to say, assume we have 100 grams. This way we can get rid of our percent, and it works out a lot better. So in this problem, we have 22.1 grams aluminum, and we have 25.4 grams phosphorus, and we have 52.5 grams oxygen. And I want to know, the formula is ALPO. So this is some number, this is some number, and this is some number. I want to know what the whole number ratio is for this compound. Again, if I multiply by the molar mass, I can know the number of moles, because the empirical formula is the mole ratio. I'm going to introduce you to this way of quantitatively setting it up. This line tells me I have a fraction, and this line tells me I'm going to multiply. I know that for every, I look up on my card, 26.98 grams of aluminum, I have 1 mole aluminum. So this number is going to give me my mole ratio, and then I have to make it into the simplest form. So once I take the 22.1 and I divide it by 26.98, I get 0.819 moles of aluminum. So now let's see what part phosphorus has. Each phosphorus weighs 30.97. So I take the 25.4 and divide it by the 30.97, and I get 0.820 for phosphorus. Now you go ahead and calculate oxygen, and I will continue on and check your answer after you're done. Well, welcome back. As you can see, I did the oxygen, and I noticed that there's 3.28 moles of oxygen, so we have the mole ratio. We can't do a 1 to 1 to 1. What we're going to do is we're going to divide by the smallest one in order to give us the simplest whole number ratio, because this is actually the ratio, 0.819 to 0.820 to 3.28, but that doesn't help us because nobody wants to know that kind of formula. That's really, really difficult. So let's do whole number ratios, which is the empirical formula. So we divide by the smallest one. Now I'm going to give you a minute and see if you can come up with the formula. Good job. I hope you got ALPO4. Because 3.28 divided by 0.819 is 4. So that is the formula. Now you look at it and you say, Mrs. Burnett, I could have known that. Yes, but you're going to be getting compounds that you're not familiar with. So it's good to know how to do this. Well, I hope this helps. Have a great day, and we'll see you in class.